Hi, my name is Franklin Kennedy, and this is Foram classification. So the purpose of this project was to classify Foraminifera. Foraminifera are single-celled marine organisms, and these organisms are very useful for environmental monitoring and assessment due to the fact that certain species of Foraminifera show up in certain environments. This can be useful for oil and gas exploration, and in particular it's useful for paleontology and the study of past environments using Foraminifera fossils. And we also did this project due to Max doing research on automated microfluidic sorting. So for our problem statement, we wanted to create a machine learning model that accurately identified 10 different species of Foraminifera. We were hoping to use this to streamline the species identification, which could aid marine research and environmental monitoring efforts. So this is an image of a Foraminifera. I can pronounce that. Here's what Foraminifera look like under automated microfluidic sorting system. Yeah. So for our data set, we gathered all of our data from MLSSforums.org, which has thousands of labeled forums with over 30 species, and these were the 10 different species that we decided to use. And every single image from MLSSforums.org has an image of a forum with a label, and they're also all different sized images. So what we did was we worked to crop out the labels for these images and reshape them all to a uniform 224 by 224 pixels to fit some of the popular models we wanted to try, trained on ImageNet. So our data, we had 10 different species, each with a name folder, 100 images per species, which adds up to 1,000 for 700 training, 100 for validation, 200 for testing. For our baseline, we used a VGG16 model initialized with ImageNet weights. So the actual model was frozen, and we didn't train that. We cut off the classification layer and added our own. We used a flattened layer, a hidden fully connected layer, and a softmax output for the 10 different species of Foram that we trained. And the accuracy we got was 60%, which it's just our baseline, so we weren't worried about it. We definitely can improve on this. So for our final model, we used a ResNet 50 with fusion and augmentation. So for this, we used 3 different images going into 3 different ResNet 50 heads. We used one normal oriented image of one species of Foram, and then we had 2 other images that were the same species, rotated randomly, and we ran these through 3 different ResNet 50 heads, and then we averaged the feature maps, flattened them, and then put it through the softmax output. And you'll notice we didn't have a fully connected hidden layer. We found that we had better results without it. And our final results were around 95% accuracy, which you see it lines up with the training accuracy much better than the baseline model. So in conclusion, our data set was very hard to work with. Gathering the data took a long time. We had to crop out and resize over 1,000 images of different forums. We had some computational limits with online resources. Google Colabs doesn't allow you to train with their GPU forever unless you pay. And also we found that we had some training and testing accuracy discrepancies during our efforts. So for future steps, we would like to implement a classification model in real time to work with a microfluidic sorting system. We would also like to expand model training to include additional Foram species, and we would like to explore a 3D convolutional neural network architecture from 3D Foram images. Thanks for watching. Have a good day.